Hello students, welcome back to my channel. Today we are going to discuss the applications of Newton's second law of motion. In last lecture we have discussed about the Newton's second law of motion and we got its mathematical formulation. What was that? That F is equal to ma. What is F, student? F is nothing but a force. What is m here? Mass of the object. And what is a, students? A is acceleration. This we already know. Now student, what is acceleration? Acceleration is nothing but a rate of change of velocity. So this is the formula for acceleration. If we will put this value of a here, what we will get here? F. F is nothing but mass into acceleration. What is acceleration value now? V minus u upon t. So here we will get F is equal to m into v minus u upon t. Now on the basis of this formula, students, we will discuss the applications of Newton's second law of motion. This is very important formula. Please keep in your mind. So many questions they will ask in exam on this formula. Okay. So what is this formula indicates? What this tells us that this force and this time, they are inverse proportion to each other. What is the meaning of that? If we increase the force, the time period will decrease, and if we will decrease the time period, force will increase. If we will increase the time period, force will decrease. With using this inverse proportion, we will study the applications of Newton's second law of motion. So what is my first application, student? Catching a cricket ball. Look here in this video. While catching a cricket ball, the player pulls his hand backward so that to prevent the injury. Now why does he do so? Why does the player pulls his hand backward? This question they ask in exams. Why does the player pulls his hand backward while catching a cricket ball? Students, by doing so, by pulling his hands backward, he is increasing the time. Which time, students? What we have here? F is equal to mv minus u upon t. So this time period he is increasing by pulling his hands backward. By increasing the time, the force which will act on his hands will decrease. It will decrease because they are in inverse proportion. Okay, by increasing the time, okay, period of catching the cricket ball, he is increasing the time period of which time period in which the high velocity of the cricket ball reduces to zero. Earlier the cricket ball is moving with a high velocity. When the player will catch that ball, that velocity, high velocity, will reduce to the zero, and the time during which the high velocity of ball will reduce to zero. By pulling his hands, he is increasing that time period, and if the time period will increase, the force will decrease. If time period will increase, the force acting on his hands will decrease, and if force will decrease, the player would not be hurt. Okay, his hands would not be hurt. Okay, so this is the reason why he is pulling his hands backward while catching a cricket ball, to increase the time during which the high velocity of the cricket ball reduced to zero. So by increasing time, the force which will be act on his hands will reduce, and this will prevent the injury to his hands. Clear this first application? Let's move to the next application. What is the next application, students? High jump. Now in this athletic event, high jumps, look here in this video also, the players, the athletes are made to fall either on the cushion bed or a sand bed. Why? To prevent the injury to athlete. Now what will happen when they fall on cushion bed or on a sand bed? The same thing, the factor is same. F is nothing but it is mv minus u upon t. When they are falling on this cushion or sand bed, they have very high velocity. Okay, that velocity will reduce to zero when they fall down. So if the time period will increase here, again the force will decrease. If time period will increase, the force will decrease. So why these beds are made cushion bed or sand beds? Because on falling them, it will increase the time, okay, during which the high velocity of athletes reduce to zero, and this would decrease the rate of change of momentum and hence the force acting on the athlete, and in this way the injury to the athlete is avoided. Okay, I hope it is also clear. Next, let's move to the next example. Now what is my next example? Yeah, very common example. These days we have seen that in all cars they are provided seat belts which are called as safety belts also. Okay, why? What is the purpose of? Question is now, what is the purpose? What is the purpose of those seat belts? Okay, now these seat belts, all of us know that they will help to prevent the injuries to the passengers in the case of accidents or in the case of sudden applies of brakes. Now the question is how they protect us. Look here now, students. What this, we know F is nothing but mv minus u upon t from Newton's second law of motion. Now when the seat belts, what they are doing, when the car is moving, the passenger is moving with high velocity. When suddenly we apply the brakes, that high velocity will reduce to zero in very short interval of time. Very short interval of time. If time is very less, then force acting on the passengers will be more because they are in inverse proportion. If one thing is increase, other will decrease, and if one is decrease, other will increase. So if time will decrease, force will increase. In that case there will be more force act on the passengers. Now what is the purpose of these seat belts? They will increase the time, which time during which the high velocity will of the passengers will reduce to zero, and by increasing this factor time the force will decrease. Okay, this means the rate of change of momentum of the passengers is reduced, hence the stopping force acting on a passenger is reduced. They may not get injuries at all or get away with a minor injuries. Clear, students? So these are the real life examples of what Newton's second law of motion. Let's recall once again all these applications. Students, first application was what? Catching a cricket ball. So many questions they ask you from this topic, applications of Newton's second law of motion in exams. So what is the first application? Catching a cricket ball. While catching a cricket ball, the player pulls his hand backward. Why does he do so? The answer is by pulling his hands backward, he is increasing the time, which time during which the high velocity of the ball will reduce to zero, and if the time will increase, the force will decrease and the player will not get hurt. Clear? Now what was the next? High jump. In high jump the athletes are made to fall either on the cushion bed or on the sand bed. Why? By doing so, they are increasing the time, which time again in which the high velocity of athletes will reduce to zero, and by increasing the time, force acting on them will decrease. Next is what? Use of seat belts. What is the purpose of that? To protect the passengers from injuries. Okay, in the case of sudden apply of brakes or accidents. Same answer, by increasing the time, these seat belts will reduce the amount of force which will apply on the passengers. Clear, students, these application? If it is clear, please don't forget to subscribe my channel. Thank you, everybody.